Okay, salam sejahtera and welcome back. Okay, so this is a new topic, chapter 2, capacitor and also dielectric. So this is very short topic. We only have 3 subtopics. So the first one, you will learn what is a capacitance and also the energy stored in a capacitor. The 2.2 is a time constant where we will learn charging and discharging process. And then 2.3 is a dielectric constant. Okay, so let us start with the first subtopic, okay, which is the 2.1 capacitor. Okay, so capacitor is a device that is capable of storing electric charges and also electric potential energy. Okay, actually this capacitor is like our storage. Okay, so it can help us to store the energy. Okay, it's similar like our power bank. Okay, so it consists of 2 conducting plates separated by a small air gap. Okay, so it's an air gap or can be isolator. Okay, so this isolator we call it as a dielectric. Okay, so the dielectric can be a mica, a ceramic, a paper, or even an oil. Okay, so the conducting plates could be the shape. So we have 3 shape, cylindrical, spherical, and also paraplate. So usually we will use in our syllabus we will use a paraplate. Okay, so the symbol for the capacitor. Okay, so this is the symbol. Okay, wait. Okay, so the symbol. Okay, so this is a symbol. If you want to draw the capacitor, so this is a symbol. Okay. Okay, next we will learn capacitance. Okay, capacitance. So capacitor of a capacitor is defined as the ratio, okay, this bar ratio of the charge Q on either plate to the potential difference between them V. So we can write the equation as C equals to Q over V. Okay, if you want to find the capacitor, for the capacitor, okay, so you can use C equals to Q over V. Okay, it's a scalar quantities. Okay, it's a scalar quantities and the unit for the capacitance, okay, is farad. Okay, or sometimes we can use coulombs per volt. Okay, or C per volt. Okay, coulomb per volt. Okay, CV -1. So capacitor is always positive quantities. Okay. Okay, what's the meaning of 1 farad? So 1 farad meaning that it is 1 coulomb per 1 volt. Okay, so this is 1 farad. Okay, so 1 farad actually is the unit for a capacitance. Okay, next one is after you learn the capacitor, we will go to capacitor in series and also we connected capacitor in parallel. Okay. Okay, so if you refer to the capacitor in series, actually we can draw in this way. Okay, meaning that the power supply connected with 3 capacitor in series. Okay, so this is the diagram. So meaning that the power supply we connect with one wire connected series with capacitor 1, capacitor 2, and also capacitor 3 in one wire. Okay, in one cycle as well. Okay, so when the circuit is complete, electrons are transferred onto the plate such that the magnitude of the charge on the plate is the same. Okay, why we say same? Because the current. Okay, the current come out from the terminal positive, it will flow through C1, C2, and also C3 in the same quantity because we only have one wire. Okay, in the same quantity. Okay, so meaning that your Q that passing through the first capacitor will equal to Q passing through Q2 and also will equal to Q3. Okay, so this is the equation. Okay, so this is the equation. Okay, next is the potential difference. Okay, potential difference. So we say potential difference because it is one wire. So if let's say only one wire, this 3 volt, for example, 3 volt, it will share together with C1, C2, and C3. If C1, C2, C3 similar, meaning that each of them will take 1 volt, and also 1 volt. Okay, so meaning that all the voltage, electric potential, it will share. The total out, it will become the total potential. Okay, so we can write as V total equals to V1 plus V2 plus V3 for series. So at the end, our effective capacitance will equals to 1 over C effective equals to 1 over C1, 1 over C2 plus 1 over C3. So this is the capacitance for a series. Okay, next one. Okay, next one is the capacitor in parallel. Okay, capacitor in parallel. So capacitor in parallel, meaning that we can draw, if really we connect with the real apparatus, meaning that one wire connect with one capacitor. Okay, and then we have connect another wire directly to from the battery or from the power supply with another wire. Okay, with another wire. Okay, and also we take another wire. Okay, we take another wire to connect the third capacitor. Okay, connect with third capacitor. Okay, so these three capacitors actually connected straight away to the power supply. Okay, straight away to the power supply. So meaning that our uh, our potential difference across each capacitor same as the power supply because each of them connected directly to the power supply. Okay, if let's say this is your power supply, so it's connected directly to the power supply, meaning that your V for, if let's say the capacitor connected in parallel will be the same. If let's say V is 3 volt, so V1 also 3 volt, V2 also 3 volt, V3 also 3 volt. So we can write it as V total for first capacitor, second capacitor, and third capacitor will be the same because it's connected straight away to the power supply. Okay. However, for the charge, okay, charge we need to total up. Okay, we need to total up because, okay, if you refer back to the diagram, okay, because when the charge come out, okay, charge or the current come out, there's a 3 wire. So meaning that this current come out from the power supply, it will split, okay, to I1, I2, and also I3. Okay, or we can say Q1, Q2, and also Q3 because I equals to the rate of charge flow. Okay, so the current and the charge is the amount of the come out actually is the same. So meaning that when they come out, the charge come out, it will split into 3. Okay, but if you compare with just now series, when it come out only one wire only connected with one wire. So the charge flowing through C1, C2, and also C3 is the same charge. Okay, so for parallel, we come back to parallel, our charge we will split into 3. Okay, split into 3. So your Q1 plus Q2 plus Q3 total up only will equals to Q total. And finally, our C effective is equals to C1 plus C2 plus C3 for a parallel. Okay, so we try first question first, and energy bit later. Okay, we try the first example first. Okay, we try first example first. Okay, so before we try, it's better we label first. We label first C1, C2, C3. Which one is C1, which one is C2? So we label it as, okay, C1, C2, C3, C4, C5, C6, and also C7. Okay, so you label first. Okay, later easier for us to solve these questions. Okay, if you look at this one actually is the terminal positive and negative from the battery. It's like connect with the battery. But sometimes the questions only use 2 dots to represent it. Okay, so actually this is the power supply. Okay, so this is the power supply. Terminal positive and also terminal negative. Okay, and usually the questions will not draw out the power supply. Okay, but you must know. Okay, so what should we do is, before that, you must refer back to the junction. Okay, so there's a two junction here. Cabang. Okay, so usually when you do, you must start from behind. Not start from the terminal, you must start from behind. So what should we do is we must, okay, we can do this one first. C1, C2, and also C3. Okay, C1, C2, C3 actually is connected in parallel or series. Okay, parallel or series. Okay, it's actually connected in series because this is the junction where the junction, the current come, it will split into 1 and 2. Okay, so this let's say this is I1. I1 will passing through C1, C2, and also C3. So meaning that they are same current, they are connected in series. Okay, so we simplify it. Okay, so this will become C1, 2, 3. This one is C4, C5, C6, C7. Okay, so just now series, we need to do it series. Okay, so C1, 2, 3 in series. So when we say series, meaning that it's 1 over. Okay, so 1 over C1 plus 1 over C2 plus 1 over C3. Okay, and the question say all the capacitor is 2 microfarad. Okay, so we substitute 2 micro plus 1 over 2 micro plus 1 over 2 micro. Okay, so we will get 3 over 2 micro. Okay, then C1, 2, 3 will become 2 over 3 microfarad because it's 1 over. C1 over. So we will get 2 over 3 microfarad for C1, 2, 3. Okay, after that, we try to simplify again. So now we do it parallel. Okay, because you see this is a junction. So actually they are from different wire. Okay, different wire. So we do it parallel. Okay, so we do it parallel. So how to find C in parallel? C in parallel. Okay, C in parallel, we use C total up. Okay, after we combine, you will get this one. Okay, so this is the terminal. This is C7, C5, C6. This is C1, 2, 3, 4. Okay, so you do parallel first. This one you do parallel first. So C1, 2, 3, 4 will equal to C1, 2, 3 plus C4. So C1, 2, 3 just now the value we get is 2 over 3 micro plus C4 is 2 micro. So finally, we will get 8 over 3 microfarad. Okay? Okay, after that, okay, we continue because we need to do until, we need to simplify until only left one capacitor effective. Okay? So again, we look at the junction here. So C5, C1, 2, 3, 4, and C6 actually is in one wire. Okay, it's connected in one wire. Okay, it's connected in one wire. Okay, from the junction. So we do series again for them. So this is connected in series. Okay, in series. So we need to do it. We need to draw or we need to simplify it. Okay, we need to simplify it. Okay, so after we combine, you will get. Okay, so you will get C1, 2, 3, 4, 5, 6, and also C7. Okay, so we do series first. Series is 1 over C1, C1, 2, 3, 4, 5, 6. Okay, equals to 1 over C1, 2, 3, 4 plus 1 over C5 plus 1 over C6. Okay, so you substitute the value, become 3 over 8 because it's 1 over. Okay, plus 1 over 2 micro plus 1 over 2 micro, 1 over 2 micro. Okay, so finally you will get our answer is equal to 1, 2, 3, 4, 5, 6. So you will get 8 over 11 microfarad. Okay, so this is C1, 2, 3, 4, 5, 6. Okay, and lastly, finally, we combine C1, 2, 3, 4, 5, 6 with C7. And because they are from the different wire, okay, this one and another one, different wire. So this is actually is a parallel. Okay, it's connected in parallel. Okay, so our C effective. Okay, the last one is C effective, or we can write C1, 2, 3, 4, 5, 6, 7 is equals to C1, 2, 3, 4, 5, 6 plus C7. Okay, where C1, 2, 3, 4, 5, 6 is 8 over 11 micro plus 2 micro. Okay, so finally, we will get 13 over 11 micro, or if you press calculator, you get 2.73 microfarad. Okay, so this is the C effective or C total. Okay, so at the end, you will get only one capacitance effective left. C1, 2, 3, 3, 4, 5, 6, 7. Okay, so only one left. And the value is 2.73 microfarad. Okay, so this is capacitor connected in series and parallel. Okay, next we will go through the derive and use energy stored in the capacitor. Okay. Okay, because the capacitor, the function is like storage. So it can store the electric potential energy. Okay, so when the switch is in the figure of close, when the switch is closed, meaning that when the circuit is complete, the current will flow through. Okay, the current will flow through. Okay, so the current will flow from the terminal positive. This is the current. And electron will come out from terminal negative. Okay, so the electron come out from terminal negative and your current will flow opposite from the terminal positive. So meaning that on your left hand side, this one will become plate negative. And your right hand side, because it's a current or positive charge will flow, so it will become a positive terminal. Okay, so when you do the experiment, you must make sure that the negative connect with the negative capacitor, positive connected with the positive capacitor. Okay, so a small amount of work is done in bringing a small amount of charge from the battery to the capacitor. Okay, so because in chapter 1, we learn work is equals to potential difference times the test charge. So when there's a potential difference and we bring a test charge, okay, so there's a work done. So similar for the capacitor, okay, when we bring in a small charge, when the charge is bringing from the power supply to the capacitor, actually there's a work done. Okay, so work done equals to V dq. Okay, so when you substitute V inside, you will get the final equations. Okay, okay, so we will get our equation equals to, again, our equation will equals to U or equals to the work done equals to half Q square over C, or we can write it as half CV square, or we can write it as half QV. Okay, so either one, it depends on what is the value you get. Okay, so depends on whether you have C, V, or you have Q. Okay, so we can either one you can use. So the work done is actually is a scalar quantity, and also the unit for the energy is joule. Okay, so it's a scalar quantity, and also the unit for work done actually similar is we are still using joule. Okay, so now we go to the example number 2. Okay, example number 2. Okay, example number 2. Okay, example number 2, there's a three capacitor. Okay, so there's a 3 capacitor. So what should we do is first you must simplify first. Okay, so you must simplify this one first. Because this is you see there's a junction here. So meaning that when the charge total come to this junction, it will split. Okay, it will split to Q1 and also Q2. Okay, this one will become Q1 and Q2. After that, we will combine here and then it will go back, okay, with Q total. Okay, and then passing through the third capacitor and then go back to the terminal. Okay, so we need to simplify C1, C2 first. And C1, C2 is the parallel because they are from different wire. So we try to find out what is the C effective. Okay, so after that, you will see C12 and also C3. Okay, okay, after that, C12, because C12 is from same wire. Okay, later we will do it in series. Okay, so later you will do it in C123. Okay, C123. Okay, so every time when you want to do this type of questions, you must find everything in total first. Okay, you must find everything in total first. Okay, so V total we already have from the questions. The questions say in the figure above, C1 is 100 microfarad, C2 is 200, C3 is 300. So the applied potential difference across is given is 8 volt. Okay, so try to calculate C effective. Okay, so now we calculate. Okay, everything must calculate. As I mentioned, you must find everything. Every time when you want to do this type of question, you must find V total, C total, Q total. So V total is the power supply, 8 volt. C total later you can find. Okay, so now we find C total. Okay, so C12 is connected in parallel. Okay, so we can write as your C12, because it's parallel, is equals to C1 plus C2 because it's connected in parallel. So it's 100 microfarad plus 200 microfarad, you will get 300 microfarad. Okay, so meaning that this one is 300 microfarad and C3 is given also 300, so it's 300 microfarad. Okay, C12 is after they combine. Okay, then you can find C effective or C total. Okay, so because it is in a series, connected in series, no junction at all. Okay, no junction at all. So it is parallel, is in series. So when you want to find series, meaning that you will use 1 over C effective equals to 1 over C12 plus 1 over C3. Okay, so you substitute inside the value 300 micro plus 1 over 300 micro. Okay, so you will get C effective, okay, is equals to 150 microfarad. Okay, after 1 over 1 over C effective. Okay, so your C effective will become 150 microfarad. Okay, so this is a C effective. Okay, so now you have V total, C total, you want to find Q total. Okay, so Q total, Q equals to CV. So if let's say you want to use Q total, you must use C total, V total. Okay, your C total is 150 micro and your V total is 8 volt, meaning that your Q total is 1200 micro coulomb. Okay, so now we have V total, C total, and also we have Q total. Okay, but the questions say, ask us to find the charge on each capacitor. Okay, charge on each capacitor. Okay, so if this is the Q total, okay, Q total will flow through C12, okay, and it will also flowing through C3, okay, C3. So we know that your Q total is equals to Q12 if you combine, and it's also equals to Q3 is equals to 1200 coulomb. Okay, so now we have Q3. Okay, how about Q1 and Q2? Okay, okay, so before that, we must find out first what is the potential difference across C12. Okay, because if you want to find Q1, you must use Q equals to CV, C1, V1. Okay, So C1 we have 100. Okay, we have 100 microfarad, but we don't have V1. Okay, but we know that if this V12 will equals to V1 and also equals to V2. So we must find out what is our value first. Okay, so I write here V12. Okay, or we can write is equals to Q12 over C12. If let's say 12, 12, 12. Okay, so Q12 is actually our Q total, 1,200 microcoulomb. And C12 just now we already found 300 microfarad. So we know that this is 4 volt. Okay, so we substitute inside here 4 volt. So you'll find out that Q1 is 400 microcoulomb. Okay, how about Q2? Q2 equals to C2V2. Okay, so your C2 is given 200. So we substitute inside 200 micro. Okay, how about V2? Okay, as I mentioned just now, because it is connected parallel. Okay, if V12 is forward, V1 also forward, V2 also. Okay, I write here, V12 equals to V1 equals to V3 equals to forward, because they are connected in parallel. Okay, so their voltage is the same. So we substitute inside here 4, you will get 800 microcoulomb. Okay, so if you refer back, to the circuit, okay, if you refer back to the circuit here, okay, you'll find out that actually total up. Okay, wait. Okay. Okay, so just now our Q total is 1,200 microcoulomb. When it comes to this junction, it will split. Okay, so you will receive Q1, just now we calculate is 400 micro, and it will go down, Q2 is equals to 800 microcoulomb. Okay, so total up 400 and 800, you will become, okay, when you combine at this junction, it will come out with 1,200 microcoulomb again. Okay, so why this one 400? C1 only can keep 400 micro, because C1, if you compare the capacitance storage is smaller, 100 microfarad. So that's why it only can store 400 microcoulomb. Okay, whereas for your C2, the storage is bigger, it's double up, it's 200 microfarad. That's why you can store 800 microcoulomb charges. Okay, because the storage is bigger. Okay, so this is Q1, Q2, and also Q3. We already have Q1, Q2, and also Q3. Okay, so this is the answer for A. Okay, B, the potential difference across each capacitor. Okay, so actually just now we already find out, okay, where we have V1, V2, and also, okay, we know that V1, sorry, not V3, this one is V2. Okay, so we know that V1 equals to V2, okay, equals to 4 volt. Okay, now we want to find V3. Okay, V3 equals to Q3 over C3. Our Q3 just now, because the total charge will flowing through, so it's 1,200 micro, and your C3 is 300 micro, so you will also get 4 volt. Okay, so actually if you total up just now, this is 4 volt, and C3 also 4 volt. Total up, actually you will get 8 volt. Okay, so this is the total voltage. So correct lah. So 4 volt, here also 4 volt. So you total up, you will get 8 volt. Okay, so this one finish, B. Okay, next you want to find the potential difference between point A and also point D. Okay, the potential difference between them. If the potential difference between them, actually this is the one that we want to find. Okay, or if you refer here, so this is the one that we want to find. Okay, so this is the one we want to find. Okay, between A and also D. Okay, so this is point A, this is point D. Okay, so from point A to point D, we only have 4 volt. Okay, only 4 volt, because from D to B, there's another 4 volt. Okay, if you compare here from D to point B, this one or we have another forward. Okay, so just now our A to D, we only have forward. Okay, so we can say, we can write in this form where, okay, our VAD is actually equals to V12, the voltage between capacitor 1 and also 2. Okay, or it can also equals to 4 volt. Okay, it can also equals to 4 volt. Okay, it can also equals to 4 volt. Okay, if let's say I'm going too fast, you can pause my video first. Okay, so this is question number C. Okay, then final, the total energy stored. Okay, when the question say total, meaning that we want to find everything, including C1, C2, C3. Okay, so if let's say the question says total, you must use total. Okay, so we have 3 equations for total energy. So your energy, okay, or you can use U, is equals to, okay, you can write half C total V total square, or you can use half, okay, you can use half QV. Of course, everything must be total. You must use total. Q total, V total. Or you can use half Q total square over C total. Okay. So if let's say I use Q over half QV, half QV. So I substitute half QV. Okay. So my total energy U total is equals to half Q total is 1200, okay, microcoulomb, and my V total is 8 volt. Okay, so I will get this one we have micro, so I will get final answer is 4.8 times 10 to the power of negative 3 joule. Okay, so this is example number 2. Okay. Okay, next one is example number 3. So example number 3 is your homework. Okay, example number 3 is your homework. So this is your homework, and you need to do it and then send it to Google Classroom. Okay, so what should you do is every time when you want to do this type of questions, as I mentioned, you must find V total, C total, Q total. Okay, then only, okay, you can find the other one. So what should you do is later you need to simplify it first. You need to simplify. Okay, here you see there's a junction. Okay, so meaning that C2, C3 is in series. Okay, in series. After that, you do it parallel. Okay, you do it C2, C3 first in series, then you find parallel. Okay, so this is your homework. Okay, that's all for today. Okay, we will see you on the next video. Okay, thank you, class.